If you've ever spent the winter in Nova Scotia, you'll notice that although the wind can be chilly, the temperature never reaches the frosty extremes experienced in, say, Winnipeg. Well, long story short, that's because of the ocean, or more particularly, the ocean currents. Ocean currents regulate climate by transporting warm and cool water masses around to different areas. In turn, climate change can affect the location of these currents and how they move. The ocean conveyor belt is a generalization of the major currents that circulate water masses around the globe. However, if you zoom into a particular area, like the Scotian Shelf, there are many other smaller currents at work too. The Labrador Current brings cold water south, while the Gulf Stream brings warm water north. The admixture of the two has a major effect on climate. Different water masses and the currents are identified by unique temperature and salinity signatures. These signatures are recorded in the sediments, meaning we can see what the ocean circulation looked like thousands of years ago and track the changes over time. Alkynone unsaturation is a proxy used to reconstruct sea surface temperature. From two cores collected on the Scotian Shelf, we see a distinct cooling trend in sea surface temperature over the past 10,000 years. Now the ocean is heating up. Globally, the temperature has gone up approximately 0.4 degrees Celsius over the past 40 years or so. This is due to global warming. The North Atlantic is heating up even faster, with an increase of 1.5 to 2 degrees Celsius over the same time period. This rapid warming has a detrimental effect on local fish populations. This affects fisheries such as the lobster fishing industry, which is an important part of the local economy. These suggest the warming in the North Atlantic is linked to the admixture of water masses in addition to global warming. A key component in the admixture of the Labrador Current and Gulf Stream is the Atlantic Meridional overturning circulation, which is getting weaker. This circulation is also a driver for the entire ocean conveyor belt, so it's very important. Using temperature and salinity data from transects along the Scotian Shelf, I was able to create section plots and identified different water masses by their temperature salinity signatures. The cold intermediate layer, warm shelf water, Cabot Strait subsurface water, and Nova Scotia Current can all be identified in one or more transect, showing us how they change through space. By looking at transects in the spring as well as the fall, we can see how they change seasonally too, or through time. It's important that we study and understand the past, as it will allow us to better predict what is to come.